probability. Example 1. A boy has 10 identical marbles in a container consisting of 6 red and 4 blue marbles. He draws 2 marbles at random, one after the other, from the container without replacement. Find the probability that A. The first draw is red, while the second is B. Both draws are of the same color. C. Both draws are of different colors. Now, let R1 be the event that first draw is red, and let B2 be the event that the second draw is blue. Now, the event R1 intersection B2 is the event that the first draw is red, while the second draw is blue. Now, to now go to A here, first draw is red, while the second is what? Is blue. So, how are we going to do that? So, the probability of R1 intersection B2 is equal to probability of R1 multiplied by probability of B2, take away R1. Because this one is conditional what? Probability. So that is the reason why by the time R1 is already taken, it will affect the outcome of what? B2. It will affect the outcome of what? B2. So the probability of R1 now. So the total marbles we have is what? 10. We have 10 marbles, right? So the probability of red is over 10. And that is what you are having here, 6 over 10. Now, since now one has already been taken, so it will affect the total now. The total will reduce to what? It will reduce to 10, to 9 rather. So by the time you now pick the 4, by the time you pick from the blue here now, it will be 4 over the total outcome now will be what? New outcome will be 9 because 1 has been taken. Is that okay? That we are writing a probability here that once you have taken R1, it will affect the what? The outcome of what? B2. Is that clear? So if this one is 6 over 10, this one will be 4 over 9. So this total, the new total will be 9 because 1 has been taken here already. Now the probability of R1 intersection B2 will now be 6 over 10, which is this one, multiplied by 4 over 9. So if you simplify this now, you are going to get 4 over 15. So 4 over 15 now, so is the probability that the first draw is red, while the second draw is what? Is blue. Now, to find the probability that both draws are of the same color, if they must be the same color now, so for that one, let R1 be the event that the first draw is red, then let R2 be the event that the second draw is also red, because they are of the same color. Also, let B1 be the event that the first event is blue, and B2 also be the event that the second is also blue. It will be either red or blue. So we wish to write R1 intersection R2 as R1 R2, that is first and second, red, or then B1 intersection B2 as B1 B2, that is blue, first draw blue, second draw also blue. Is that clear now? Now, so we wish to write to find probability of R1 R2, that is red, or means union blue. So if they must be of the same color, it will be either red or blue. So the probability of R1 R2 plus probability of B1 B2. So since R1 R2 and B1 B2 are mutually exclusive, so the probability of R1 R2 will be probability of R1 multiplied by probability of R2 take away R1. So once you have taken the first one without replacements, then it will affect the total outcome. The total outcome here is 10. So once one has already been taken there, then the total will reduce to what? To 9. So the red is 6 over 10 multiplied by, for the second draw now, for the second draw. So since it is red, you have taken one from red before, then this one will reduce to what? To 5 over 9. The total has already been reduced to what? To 9. So if you simplify this now, you are going to get 1 over 3. The same thing for blue. So probability of B1 now. So the total blue that we have is what? 4. and the total is 10. So 1 has been taken from the blue before, it will reduce to what? To 3. Then 3 over what? 9. It will affect the total also. So by the time you simplify this one, you are going to get 2 over 15. Is that clear? Now the probability of red red or blue blue will now be equal to this 1 over 3 plus 2 over 15. So by the time you hatch this one now, if you simplify, you are going to get 7 over 15. Is that clear? The third one, the event that both draws are of different colors. They are of what? Different colors is what? Is either the first draw is red and the second is blue, or the first is blue and the second is red. So this is the probability now of R1 B2 or B1 R2, which is equal to this. And then since this one are mutually exclusive, since they are mutually exclusive, so what we are going to get now is probability of R1 multiplied by probability of B2 take away R1. So probability of R1 is 6 over 10. Is that clear? Now for the B2 now, the total is 4. You want to take from that 4, it will be 4 over 9. It is 4 over 9 because, you know, the total has been affected here now. 1 has been taken from the total. Is that clear? So once 1 has been taken, it will reduce this what? So the total will be reduced to what? To 9. So by the time you simplify this multiplication now, you are going to get 4 over 15. The same thing is applicable to either the first one is blue and the second one is what? Is red. So if you take first from the blue now, it will be 4 over 10. The second one, which is red, 6 over, the total outcome has been reduced to what? To 9. So 6 over 9. By the time you simplify this now, you are going to get 4 over 15. So the probability of this union this now, that is probability of red blue or blue red, is equal to 4 over 15 plus 4 over 15. So by the time you simplify this now, find the LCM 15. So you are going to get 4 plus 4, which is equal to 8 over 15. So this will now serve as the probability that both draws are of different colors. Is that clear? Now, if that one is clear, let's look at another one. Example 2. The probability that Abu solves a particular problem is 1 over 3, and the probability that Bello solves the same problem is 1 over 5. If both attempts the problem, what is the probability that it will be solved by at least one of them? Now, the probability that it will be solved by one of them is at least one of them is either this one, Abu solves the problem and then Bello fails, or Bello solves the problem and Abu fails, or both of them solved the problem. Is that clear? Both of them solved the problem. So we can still look at it in another way. So which is the approach that I use here. Let E1 be the event that Abu solves the particular problem. Let E2 be the event that Bello solves the particular problem. Now, let this one be the complement, that is E1 bar E1 be the complement of E1, and let bar E2 be the complement of E2. So let E ordinary be the event that at least one of them will solve the particular problem. Then the probability that at least one of them solve equal to 1 minus probability that none of them, because the probability that at least one of them solve the problem or none of them solve the problem is equal to 1. So probability of E plus probability of bar E1 by E2 is equal to 1. So by the time you now make this one the subject of formula, it will be 1 minus what you have here. Now, since E1 and E2 are independent events, they are independent events. Is that clear? So we're going to have probability of by E1, E2 is equal to probability E1 multiplied by probability of E2, because they don't have anything in common. Is that clear? So they don't have anything in common. So the probability of E now is equal to 1 minus probability of by E1 multiplied by probability of by E2. So the next task now is to find what is the probability of by E1. So the probability of by E1 will be 1 minus probability of E1. So, and that is what we have here. Probability of E1 is equal to 1 over 3. So to get the complement of this one, just say 1 minus 1 over 3, which is 2 over 3. Then probability of E2 is 1 over 5. That this one is given. So to get the complement of this one, just 1 minus 1 over 5, which is equal to 4 over 5. Hence, probability that at least one solve the problem is equal to 1 minus, this one is 2 over 3 multiplied by 4 over 5. So by the time you simplify this, 2 multiplied by 4 is 8, then 3 times 5 is 15. So 1 minus 8 over 15 is equal to what? 7 over 15. So this is the probability that one of them solve the particular problem. Now, if this one is clear now, I would not like you to do this one for me.